This is GS Programming 2, GST 8010, Module 07, Lecture 1 of 2. And we're going to take a little bit of a deeper dive into the ArcGIS JavaScript API, aka ArcGIS Maps SDK for JavaScript. I'm instructor Robert Hewlett, and you can contact me via the email address below. The general learning outcome is to master, know, and understand all content, concepts discussed in lab, lecture, and the assigned readings. The specific learning outcomes, although not an absolute list, is to describe the use of the MVM pattern in the SDK, distinguish the possible layer types that you might encounter or have to create and place on a map. Also, their corresponding layer views, if they have one. Distinguish the geometry types that you might have to work with when you're using ArcGIS JavaScript API. Distinguish the possible portal types. So you do have the ability in the API to query the portal, much like the, I guess it's called the ArcGIS API for Python, which is, I won't talk about the naming there, but it is about using Python to query the portal. So you have some of that same capabilities in the API, except you're doing it in JavaScript. Discuss symbology in the JavaScript SDK, Maps SDK. So the one thing here is going to be light, sort of a high-level discussion, and we can dig deeper into this in the future. Distinguish the methods of the reactive utils, I guess, module. Very important if you want to have that. Well, one obvious use would be that dashboard effect, where the map is moving, things are changing, and other parts of your page are updating based on that. That's one way to use them. Create and register event handlers. So part of reactivity and the base of reactivity is having your code hook into some part of the interface. That's critical. Otherwise, you don't know if you clicked on something or if you should be doing something or not. It's the basis of a lot of this. So quickly talk about MVVM. It's an application programming pattern that we talked about in the past, and so there's ways that you can take advantage of it in the SDK. So we've talked about this in previous lectures, but does it exist in the JavaScript API? And if it does, how could I leverage that? Right? And so this model view model pattern in that. So model view model. So although it's there is this concept model, that's your data, right? Your data. One way to think your data is like a JSON file. There's a bunch of key value pairs in there. It's just values, the model, how it's structured. The view is that the part that the user interacts with in that. Just so you know, that's the part that the user clicks on. I guess if I was to show this, I'd have to put the view model in the beginning in that as well, right? And so that the view is that user interface. There was a web page that got loaded, and the user went to one part of it in some div, and they clicked on something, and that. And so that's the view that you are presenting to the user, and that. The view model is the business logic, and so there's this separation of concerns, or even further, deeper separation of concerns in that. We have this concept of separation of concerns. Our code is, we're trying to follow that, a local EM pattern where in using VS Code, that our JavaScript's in a JavaScript file. Our data is in a JSON file. Our user interface is in an HTML file, and maybe some cascading style sheets in that. Yet further separation of concerns. But this concept in programming, this view model, is to further tease apart that thing that the user clicked on, the data you have in the back end, and that is another little go-between in that, right? And it is to make the view as dumb as possible, right? And that's not a slight, right? What that is that it gives you the ability to change the view out really quickly, or present to the user a different view. And by presenting the user a different view, you create that different user experience, right? Of how do something as simple as how do you zoom the map to the home position, and that does it have to be a widget that floats on top of the map, and that sort of thing. And the answer is no, it doesn't have to be. And so you may want to do it differently for your users in that, and not be tied to that. And this model view model pattern does help you do that, right? Another thing that helps, like I said, I'm saying here, is testing, right? Because if you're going to test your code, right, and the only way to test the code is to click on the view, that's a problem, right? You get a bunch of people in the room, hey, click on it, get everyone click on this, in that, versus trying to do some automated testing in that, where you hammer on the view model instead. And so you can, code your tests in that. A big thing is what I was describing before is that a different view for the view model. And that leads into, well, you having that, different user experience in that. So most of the widgets that are part of the SDK/API do have a view model. Not all. There's a couple that don't. In that, you you use your own view model, right? Or your own view, not so much view model. I should back up there. So you can use your own view, right? And so you can take advantage of the fact that the API has figured out, I guess, presents to you a common way to get back to your initial extent. Because initial extent can be set so many different ways in that. It could be where you first told the map to zoom. It could be something that's embedded in the web map. It could be a thing where you want to load a layer and zoom to the bounds of that first layer loaded. Or there's a bunch of layers in the map and you want to zoom to their combined extent. So it might be a bunch of different ways of setting that initial extent kind of concept in that. But you want to put on top of that, that's business logic, how that's done. But on top of that, how does my user say, hey, go back to the initial extent, right? A good example could be your view, right? Here's a different view. I want to have the ability for the user, for accessibility purposes, to say home or map go home. So they're not clicking on anything, right? It's like a voice command, a completely different user experience and that sort of thing. But you can still leverage the business logic of that initial extent concept via the API. But what you're playing around with is that very front end, boots on the ground experience in that. And so we can go and take a look at this sample. I'm not sure if it pops off screen, I'll just slide it across. Oh, it popped in here in that. And so in the lab, we use the built-in layer list widget, which has the little eye symbols, and you can turn them on and off. It is very different, just so you know, right? This is a div with a span in it and a simple checkbox in that. And so some of them wanted a different way of turning the layers on and off in that. So this actually presents to you it's still a widget floating above the map, but it is a different view in terms of checkbox. Maybe, there's a new internet fad where everything has to be a toggle, right? And needs a little slider and that sort of thing. And so it gives you the ability to chase those fads, chase those trends without, reworking a whole bunch of code. What you're really playing around with is how it looks to the user and that. I'm going to go full screen here for a sec. Also, I have a demo video in the playlist, so take a look at the part 2 video where we do the home button differently. So we do leverage the view model, but we're not using the widget that is floating above the map. Instead, we're using a calcite button that's off on the side. There's a complete list here in that. So I have all the view models, and I've identified the ones that actually, well, no, all of the views and their models, and the ones that actually don't have a view to go with it, and that. And so we'll get into a little bit of a warism, right? To solve problems over time, right? To the stack, we add layers in that. Um, and so that's a common trend in a lot of systems, right? So we evolved from one-tier systems to two-tier systems to three-tier systems. And this is really just dealing with, I've worked on Unix boxes with Arc Info, and then you go client server uh, with map and pro with data back in the enterprise and enterprise-enabled geodatabase, and then it's more like three-tier systems is where you have something like ArcGIS Server involved. There's usually a database in the back end that feeds ArcGIS Server, then ArcGIS Server feeds JSON to your browser that it can understand. And you can just keep injecting more layers in there to solve a problem in that. And so, in this, keep separating things out more, right? And so that middle tier ArcGIS Server, in the end, it tells the database to save stuff, but it's not its job to save it and do backup and recovery and that sort of thing. This is someone else's job, but it's that go between in between the back end storage and that, and we'll say the front end, someone in a browser clicking on it, right? So does this add complexity? Yeah, every layer you add adds complexity, and nothing's for free, and so there's always going to be a bit of a hit, but everything's a trade-off, right? Uh, in that, uh, and so in a code base to support MVVM, I mean they got to throw more code in there, but there's payoffs when you want to do something different with the view and that. So we'll talk a little bit about reactive utils in that. So it's a very small module, a few methods, but very important in that. So if you want to watch something and then react to it changing and that. So watch is really about maybe watching different properties on objects. You have this object has lots of properties if we're going to use the nomenclature of the SDK API. And so there's a property that you want to watch. You have to write it in a function in that, but in the end you're tying to a property that you are watching on an object, and when it changes, so it could be a string object, a number object, and that sort of thing. And so when it changes, you want to do something differently on the page or update something typically and that. And so it returns you a watch handle that you can destroy later when you don't need it. When you fire one of these things up, it's kind of constantly running until you tell it to stop, if that makes sense. And then there's like once. So it's like watch, right? Uh, but it's like, when it first happens, I'm already concerned when it first happens and that sort of thing. So the first time it happens, let me know in that. And so then it's different. It doesn't do a watch handle that you can destroy later. It's done as a promise because it's going to, once it does its task, it's going to get out of the way and that sort of thing. There's also something called when, and so we're still watching properties conceptually, but truthy properties. So there's a Boolean. So there's lots of stuff like on a map, are you stationary? Yes, no, right? Or you just did the map just moved and the layers view is updating, right? Getting data and applying symbology, and you're like, okay, are you done? Right? Are you still updating? Or are you done? So it's very similar to watch, but because you're watching true false values in that. And so it does in terms of readability, it's almost doing the same thing as watch, but in terms of readability, right? In that. View.watch, does that make sense? View.when ready, right? That makes the readability makes more sense and that sort of thing. In that. And again, you write a little function that returns true or false, and then based on true, we do. And so when will return you a watch handle, because then this is kind of like once you fire, you start this up at the beginning of your app, and it's kind of responding, listening the whole time in that. But there might be a point in time where you want to get rid of it, the handler, right? Or when once. So this is like once above, but again, this is, hey, the first time this changes. And the first time this truthy value changes is when I want my code to kick in and that. And so it gets into what kind of a property are you watching? String, number, date versus truthy. Do you need it to be running for the entire, as long as the app is running, you need to be responding, or is this something that just happens in the beginning? In that. There's also on, but on's like a different thing. You're really watching the not so much the property, but the object, the bigger thing in that. And you're watching, uh, you know, you're watching people adding and removing listeners and that. There is a property on this when you make them called once. So do you need this to happen? Do you need to be listening for people doing this the whole time, or do you just need it like in the beginning? So there's lots of stuff when the map, when your app first fires up and the map is first coming in and the layers coming in. So there's going to be stuff you just need. Hey, I just need this done at the beginning to be set up, and then we're fine. And then there's other stuff while the app is moving around, doing its thing, pan and zoom in, responding to people selecting different things in the list. You need to be listening all the time throughout the lifetime of the app while it's running and that. So this has, like I said, it has you're looking at something bigger. This is really about event listeners being added and removed from an object, uh, and then there is a property when you create one of these with the method of whether you need this to be happening all the time, or is it just a once deal. So what you can do now is pause this video lecture and watch the demo, where we just watch the map. It's very simple, just a few lines of code where we just watch the map and we can tell that, okay, it's moving around, and we can tell when it's kind of like idle or stationary in that. So there are many layers, right? And I mean many. There are many because there's many spatial formats out there. And that actually wouldn't hurt to take a look. And so you have lots of different base layers, and lots of people who have base layer services like Microsoft over it with Bing, and that CSV layers, you know, much of a renaissance when we're talking about cloud storage and the S3 over at Amazon. Lots of data in CSV format available via the web. Feature layer, I'll say it again, king, and that sort of thing. And of course, GeoJSON, very popular. There's still RSS feeds out there, and that is older technology, but still kicking. And that graphics layer, magician. Usually used to solve all types of problems in apps, and that if you need to draw on top of the map, if you need to show a selection set, in that if you want to dynamically let someone drag and drop some data onto a map, then you usually load it into a graphics layer to solve all those problems. Our friend group layer, in that lots of different types of layers, lots of different services that get supported. KML is another one that just won't die off. It's interesting. And uh, a lot of OGC, the OGC feature layer, which is actually OGC features but done as a REST JSON, and then all the down at the end here, all the classic OGC web coverage services, and that web tile services, web feature services, web mapping services, and of course all the Easterrise own services they support as well as a different type of layer. And that vector tiles over at Mapbox, right? A very important one. Tile layer is a image tile service in that. I don't know if it's not quite zippy tiles in that. It's a little bit different in that. So tons and tons of layers. And this lists every version of ArcGIS Server Enterprise. There'll be more, right? There'll be more and more. Uh, and that. Never ending, just so you know. Uh, Now, we'll try this. Yeah, there, that worked. And that sort of thing. Like I said, so there's many spatial formats that you can access directly. KML, CSV, depending. The CSV one, I wish it was GeoCSV and well-known text. That would be awesome, but not. Um, but also lots of different services that you can talk to, right? So there are ESRI services, but there's also the OGC, and then there's just popular companies like Microsoft with Bing and Google and that. Oh, like I said, lots of different base maps. And I'll say it again: feature layer, king. Get to know it well. the feature layer and the feature set that gets sent to you. Uh, and that. So this is the hosted feature service that we use in that. So inside a hosted feature service, many feature layers in that. And when they get sent to you in your browser, it's a feature set. And so no getting used to that format, only, for the purpose of what is capable with this data that they'll send me. And that. Lots of the GeoJSON uh, and that. These are highlights in that. And again, the magician, that graphics layer solves so many problems, especially when we're talking about interactivity or things being dynamic, right? And, you just slide a layer on top of the, add it to the view and then put your data on there or whatever you happen to be doing. A lot of the widgets that you drop on, like the sketch tool, have a graphics layer built in. That's what they're using to draw on top of in that. And all those great OGC feature services. Yes, and what is the difference between this new, well, relatively new, in that it's been around for a while, the OGC feature service versus the web feature service. It's a difference between uh, REST versus SOAP and XML versus JSON coming at you. And the JSON that's coming at you that AJSAPI supports is that this service has to be spitting out GeoJSON. And so those are the layers, but then there's these view layers, right? And so layers are things that are back on some web server somewhere, usually. And view layers are layers that are in your map view, right? So, I guess we could go client side, server side is one way to look at it. And that. And so this list is actually smaller, right? It can fit on this slide, right? In that. Um, the the way I interact with view layers is usually to get at the data. So if it's a base layer view, well, I mean, it's just usually background images. But if you're doing like scene layer, building scene layers or dimension layers or just scene layers in general, if you need to select on them and query them, and if you've loaded some CSV data and you need to query it, or a feature layer and you need to query it, the thing is you have to get down into these views to see what they really support, right? And that. So you have to go to inspect the objects. I'm spoiled because I'm usually talking to a feature layer view, so I know I can query it via uh, via the style of the ESRI REST JSON API in that. But you might need to be able to have the built-in querying in that as well. In that. But the big thing here is that when we're talking one of these things, layer with the view on the end of it, this is where we go to the map view and we pull first, you're not a layer on a service. We have to have a map view with a map, and you have to be a layer inside that map view in that. And we're pulling usually, not always, usually pulling it on the client side to do something with it in that. So once they're on the client side, there's something that you need to happen in that. Now, image layer view kind of interesting, but maybe you need to dynamically turn off, different layers and that. Different than querying, but you do have a view that you can manipulate on the client side without having to go all the way back to the server uh, to change something or get new data. That's why these exist, right? There's something that you want to do on the client side, and you might be way faster to do on the client side than to go back and to the server and pull a bunch more data in that. And point cloud layers view. What if you want to change how they're symbolized real quickly instead of pulling the data, especially billions of points from the server again? Just deal with the ones that you have locally. And then stream layers as well. Stream layers are like this is like the real-time event processor streaming data out. Things are changing all the time, and that. And so there's I guess two ways of working with the data. Are you going to go to the view layer and pull its layer? But you might end up, if you do this, you might end up back on the server, just so talking to the server, and that sort of thing. But it also, if you, and this is, I should say this, I'm saying feature view layer here, dot query features, because not all of these views above have a method called query features, and that. But the feature layer does, and so this would be different than running, view layer dot layer dot query features means I'm going all the way back to the server. But feature view layer dot query features means I'm querying stuff that's on the client side, or that's the concept. So talk a little bit about querying data in that. One, your layer or your view layer needs to support it. So we'll start there. But the concept will be, are you going to do server side? So if we got a layer, not a layer view, but a layer, right? And it was a feature layer, and we said feature layer dot query features, then what's going to happen is we're going to query the service all the way back on the server. And therefore we have all features in the service potentially available to us, all fields and stuff like that, and that. Now, there is a concept of a client-side query, and that's where we go to the view, so the layers view. So the layer view has to support it, and the feature layer view does. And so if we go feature layer view dot queries, then we kind of features that are local, right? Now this is going to take some fine-grained testing to see what's really happening in that, just because of the way the documentation is written on query features in that. If you go there, and there's a link above, and you look at the query, they talk about parameters, and just a little bit, a couple lines down below, they talk about a query. We used to call these query parameters, and that, and they talk about to set the geometry of this query parameter to the view of the map. I'll do some testing to see if that's really real or not, if that has a different effect. It'll be interesting to find out in that. But these query parameters, again, that's what used to be called back in the SOAP XML days. That's how I remember from the early SDK days and stuff like that. And that, who knows what, if I was on Android or somewhere else at the time. But there's a geometry restriction. So when you do a query, you can, send in a feature, say, hey, only features, that interact with that are close to this feature. In that, typically, what you might want to do in our case is we'll take the box that represents where the map is currently looking, so map view dot extent, and say, hey, only features inside this box, and that, or interact with this box is another question. Do you have to completely inside and that kind of stuff, and that. There's usually a where clause, so you can you don't have to use it, but you can say, hey, only where fire hydrants are red, and that kind of stuff. Return geometry. So when the data is coming back to you, do you need the geometry or not? So you can really speed things up if you don't need the geometry. If you're going to zoom to a feature or something, you need the geometry, and that all depends. Outfields. When you do a query, do you need all of the fields of the server, of this, I guess, of that layer, or you just need a couple? Again, like, what if it has, like, is a hyperbole to say 50 columns? No, I've seen some really wild data sets with a lot of columns on them. And so do you need them all or just a couple, right? And that just might be one or two columns of interest that you need. So just narrow it down, less data, faster, and that. Order by fields. You're gonna have a double for loop, bubble sort the data on your side, or you're just gonna ask the service, hey, when you send that to me, tidy it up in that. So you can control what rows, the order of the rows, what columns, that sort of thing, whether you need geometry or not through this query parameter concept or this query object that you feed into query features in that. And that, like I said, the geometry stuff on a local query, we gotta see if that's already restricted that way in that. And it takes a little bit, different type of testing to really, dig in and say what's really happening in here in that. Oh, and our friend, look at that, our friend. Usually we'll back up. the, Usually when you do a query like that, using those types of things, you're expecting like, hey, I want all the features that match these conditions, sorted, and then I decide how much info I want on them and that. But the idea is like many, right? Uh, uh, 0 to many is coming back. If you take advantage of this out statistics, what you're saying is whoa, 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 right? Whoa, whoa, whoa. I don't want the individual features. I want to typically aggregate them somehow, and I need like a count or a sum or an average, min, max. And so then you're not going to get a many coming back. It'll still come back as what we call a feature set, but you're just going to get one row back in that, much like if you're in a database. I think I've done this example before, and you go select now. right? So we're in pgmin4 going select now. What gets returned to you? Hey, a table gets returned. It just happens to have one row, one column with the current timestamp in it. In that. And so if you use dot out statistics, it's just very similar thing where you're going to get like typically one row back. You might get many columns representing all the stats that you wanted and that sort of thing. But the operating unit, just like in a database is a table, the operating unit in this thing is like a feature set. So let's talk about summarizing data. You can get the server to do a lot of work for you. So how do you summarize JavaScript objects? Because if you got a feature set returned and you didn't use out statistics, then it would be no, you, right? If you needed a count or a sum or an average, a min or max, usually count you can cheat. You go, feature set dot features dot length. That'll get you the count and that sort of thing. Well, these are standard SQL aggregates that are I think are well known by a lot of people when you bounce around information stacks like we do. That you're looking for this. So if you get many things back where you just want it like a total or a sum, right? Then how do you do that in JavaScript code? Well, lots of ways. There's, like I said, you and a for loop looping over all the features, doing a sum or an average and that sort of thing. So you writing a lot of code in that. There are other products out there because this is a thing that people run into. Is you have this big JavaScript object with lots of data inside, and you just want to run summaries on it. So there is something called JSON path. It works very much like XML path in that, and it has a query syntax that can do these concepts, right? In that, there's JSON ADA, which is kind of like an improvement uh, to JSON path by IBM to make it more flexible to do your queries. But it's almost like learning another language, if I'm honest. The for loop, at least you're still in JavaScript doing your own thing. Or you can incorporate these technologies. One that I saw on GitHub that I actually kind of liked because it uses words like group by, min, average, sum. And so it's a very SQL style JavaScript library for rolling up stats on a JavaScript object where you might have like a many deal and that. So there's lots of people run into this problem. That's why we have all these solutions. I mean, in the end, if it's a quick one, you in a for loop is fine in that. However, the SDK, so the JavaScript API for ArcGIS and that, right, built into the query parameter is this out statistics concept in that. And so there's a link here. And so, like, why is it there? The reason it's there is because it's something that the hosted feature service can do, right? So this is built into a hosted feature service. Basic statistics have been there for a while. So I think this out statistics is interesting in that. But you have the ability to get the service to crunch the numbers for you. Hopefully the server is running at C++, C speed, and it can do these types of. You're hoping that it should be optimized to do these queries fast, right? It's in their best interest to make this quick on their side, in that. And so instead of you doing a bunch of for loops or having to learn a new sort of syntax and bringing in other libraries because you would have to like import these and make them part of your project, you can just get the service to do it, or in this case on the local part, because the same kind of capabilities is built in to do local searches as well in that. And again, it's part of the feature service REST API specification in that. Actually, let's pop it and take a look in that. Close some of these tabs down. And so if we go down here, this is the ArcGIS REST API for a feature service and that. And so it's a feature service, a layer within a feature service. And this would be the actual box. Like to do something outside this box would be tough in that. And so if this feature service can't do it, then the API probably that would be a restriction on the API. And so you get down here, there's your where clause. Do you just need the object IDs? Is there a spatial restriction in terms of geometry? A spatial filter, basically. Oh, and you can do fancy stuff too, right? in that. If you just send a box, I think you can do predicate searches in that. Spatial reference information in case it's different, timestamps and all this. Outfields, what fields you want to come back. If you don't need them all, don't. The star is how we uh, get them all to come back. Do you need the geometry and that? And again, it's all these things we see in the API. We're seeing them repeated here, right? Because this is what a hosted feature service is, and this is what it can do, and that. And then the API writes code to support this. Having, our friend SQL, I like that. Group statistics in that. Um, in that. If we keep scrolling, order by fields and that, there is a ascending, descending option, just so you know. Is it baked into the API? This would be a really good question, something to look for. And that group by field statistics, right? And this is the stuff that I used to, group by fields. But then there's this out statistics concept as well. And so we build one of these JSON structures to say, look, I need a sum, a count, an average, and a min and max kind of deal. And that. And so again, the reason like we see this showing up in the JavaScript API is because this is what the hosted feature service is, and it's they want to support all the things that the hosted feature service can do because it's theirs. In that, and that. So what you can do now uh, is pause this video lecture. And although I have two slides that say server side, client side, I do believe in this one video I demo both in that. Again, there is a demo video in the playlist that shows me doing server side and client side. So just want to go over a quick comparison between client side, server side that I noticed, right? And so I can save you a lot of time because I burnt a lot of mine in that. They're not identical. That's going to start out right away. It's not identical at all. Okay, but almost makes sense. I've seen this where they introduce a feature in the enterprise-enabled geodatabase, and years later it shows up in the file geodatabase because they would have to add all that code. I guess the enterprise-enabled geodatabase is leveraging Oracle and Postgres to do a lot of the work in terms of triggers and stored procedures and that, and then they would have to mimic that whole capability in code base in Pro to give the same behavior on a file geodatabase. So you have this service that has all these capabilities, right? And it's written in another language, and that C++, and for them to do a local search, then they need to like recreate all that code and functionality over in JavaScript, right? Because again, the hosted feature service servers, part of it might be like a REST JSON thing, but you might be making calls back into some C++ code that actually does all the work in that to make it really fast. But then they have to mimic all those same concepts on the browser side and do that in JavaScript. And some things might have to change a little bit, and that. So I'll forgive them in that. And so they're not identical. So if the first or off the bat, you don't even go to the same thing, right? You go to feature layer. If you're server side, you deal with this thing called feature layer. And if you're client side, you're dealing with this thing called feature view. And it's really easy in code to mix it up and cross over or accidentally step in, hey, I was on the feature view, but then I went .layer and oops, now I'm server side. And that. And so it's really easy in code to all of a sudden slip and be on a different object and you're not doing client side anymore. Outfields was very different, right? On the server side, I didn't say anything. If you go back and check the code, I don't even specify an outfield, and I get them all, right? And that sort of thing. I didn't have to go star on that, and that sort of thing. So I get them all in terms of what? In terms of doing query statistics, they are all there for me to pound statistics on, and that. So on the server side, and it probably was because I wasn't requesting the features and had to specify what outfields I wanted. Because it was a stats field, they were automatically all available to me via the service in that to calculate stats. Well, on the client side, I actually have to force shape error to come over. So the client side is highly optimized, right? So that view, the feature view layer has just enough information, right, to get that layer drawn. And so one column that was coming over was my age class. I say it in the demo because the H class is used on the unique value renderer. So it's like, well, I need that one just so I won't be able to assign the colors properly. So that had to come across, but it says all these other ones there and I don't need them. And so they don't come over. And so there's a little line you got to put in to say, hey, outfields, I need this one. Otherwise, I can't do stats on my side because the stats aren't being calculated back in the server. They're being calculated in your browser client side. And that. Query syntax, one thing I ran into, I was able to say is equal to null when I was talking to service, right? And that's not quite proper syntax in that, but it let me do it. But no way on the client side, I have to go is null. It's a subtle thing, but you're sitting there, why isn't this working? And you go check your code, why? I'm saying null, and then you check it a whole bunch of times. You go, okay, well, technically, like equals working on the server side, and I'm like, well, I've been around databases a bit, so how about is null? Try is null. Oh, look at that! It's all of a sudden working, and that. The trigger, right? Because we were going back to the service to get the data, right? We can just wait for the map to be stationary. It's okay, the map is stopped, go query the service real quick, get the latest data, boom, done, right? However, when we're on the client side, the map might be stationary. Hey, the map is stopped. This is always it's frustrating, but almost at the comedy level because it's always the issue. When is something ready, right? And that. And one thing too, when the map view is stationary, positive, yes, it is stationary. On true, it's good to go. And here I'm going on false, not false, to get to true, and that. And so I have to wait for the layer view to say, hey, I'm not updating my data anymore. And what that means is, hey, the map moves and stops. And then the layers kind of, okay, we got to go get more stuff. And so they go back to the service and pull the data over, right? And they also have to apply symbology, I think. If you dig deeper into the help, that's what they say. I mean, again, as much as I love docs, and that the truth is in the code. This we find out real, if something in the docs isn't quite the way it is in code, and that. And so when the layer feels that, hey, I'm updating, like requesting new features that are out of scope, that were out of scope but that now are, and I've already applied symbology, so I'm done, basically. I'm not updating anymore. I'm done. Then it was okay for us to query the client on the client side. So this is definitely close, right? But there's some little gotchas here that can burn a lot of time and that sort of thing. Switch gears here a little bit, talk about geometry engine. What is it? Yes. One way to look at it, client side geoprocessing, right? Maybe you're doing a test like a predicate test. Does this touch? Does this contain? Maybe you're measuring things. You're calculating areas and that. Maybe you're analyzing. I need to take this point, buffer it by a distance, take that buffer, clip this veg cover, and then figure out how much stuff I have inside there and that. And so when you're analyzing, you're usually involved with two or more geometries and that. Then your clip being symmetrical difference and that, all that kind of stuff. Lots of different predicate Boolean tests, contains, crosses, disjoint, overlap. All our friends that we've talked about in other courses with me in that. If you're doing analysis, and there's a big thing there, one's true false coming back. Here, a new piece of geometry is being created and sent back to you. So are you buffering geodesic? I don't think I said that right. Buffer and that, but that's where you are buffering on the surface of a sphere, right? It's not Euclidean. So this is like a Euclidean or planar kind of concept. More planar. It's a flattened buffer, right? So you're on a projected type of map coordinate system, UTM, Web Mercator, and that BCL bears, best projection ever in that. Or are you doing it on the surface of the Earth kind of concept? And that would be a polar one. It's a sphere, surface of a sphere, and that. Are you clipping something? You're taking a bunch of points and figuring out the convex hull or other shapes in that. Are you cutting them? The difference between two shapes is symmetrical difference in that. Are you unioning two shapes, intersecting two shapes in that? This is like, this is like, you can do a lot of geoprocessing here, right? You can also slow your app down too, just so you know, if you do a lot. Your app could get janky in that. And then sort of, I call this modifying geometry. And versus, you are kind of creating new geometry, but it's the old one, and it's flipped horizontally, vertically, or maybe it's just less vertices generalized, or you're offsetting it, right? Go, hey, take this and nudge it to the north by a few meters, to the east, to the west, kind of deal, and that classical translate thing, and then rotate. So. And this, symbol rotation does come up every once in a while. So where I saw it recently was there was a map of drains in that, so their location, but the symbol, they had a standard symbol for the drain, and it would have built into the symbol which way the water was flowing towards it. And so all of those symbols were rotated and that. So say you had a thing like this. Hey, we need to place a drain here, right? Like a catchment drain or basin drain, some type of drain, like for like let's say, yeah, stormwater in that. But we need to indicate also the direction that the water's flowing in to get to that drain in that. So you may have a symbol that has like a little arrow built into it, and you need people to actually be able to rotate it and that. And so actually an important thing in that, I would say. And then, if we're dealing with geometry, like in a geometry engine, it also helps to understand what kind of geometry you got. There's a bunch of properties on geometry like cache, right? And so if a geometry shape is changing, like a polygon, that would affect its centroid, its area, its length, perimeter kind of concepts. Also affects its extent too. Extent is that, like, abstract. This shape is over here somewhere, minimum bounding rectangle deal. Oh, I mean, it may sound weird, but all geometry has an extent now. There was a time when they didn't put it on points, but that means other people, when they're searching, uh, sometimes you just need everyone to have an extent, and we'll be fine. Even though the extent would be very small, in that, does it have measures? Does it have Z? Are you dealing with 3D stuff? Right. Spatial reference is pretty important, right? Especially if the geometry you're dealing with is in a different spatial reference than the map or layer that you're looking at in that. And what's going to happen? And then it's type, right? Point, multi-point, polyline, polygon, extent, and mesh. And one that's been around a while, but I guess I've been ignoring it. Well, circle, what type of geometry? Yes, type of polygon specifically in that. So optimize circle, and so you can do a circle. You can describe this concept of geometry as a circle, which would be a radius, right? Diameter. I mean, a central point and a radius, and that sort of thing. It will be, I think, in the background turned into a polygon in that. So it's a type of polygon, but it's something you could run into, right? I mean, buffers are like kind of like this. Geometry related classes that get into this projection. So that concept is, what if my spatial references are different? Do I need to project them into the same one before I start doing analysis? And that. So there is to actually do the projections, like change it from one to the other one, get all the transformation, get a transformation from an object, or get all the transformations available in that. And of course, spatial reference is a big object in that. You either capitulate and do everything in WebMacator or 4326, right? The 1.5 projections I talk about. In that, you capitulate and do everything there. Or, it's important that our map be in UTM and that we are able to, but they're on their phone, so it's going to be a lat long. We're able to get it from the phone and on our map properly. Reacting to all this stuff, people clicking on your app and doing that, you have to get into the events and event handlers in that. So this is the, foundations, we'll say, of reactivity. People build upon event handlers to get the promises and stuff like the reactive utils where we're watching something. But a lot of it, under the hood, if we keep digging through the layers, we'll find some event and some event handler. And so there are many events. There are a bunch of window events, and there are a bunch of document, which you might get involved in, usually. You could get involved in a little bit in that. Document events, maybe not in that. It's a small list, right? It wouldn't hurt. and that. And so here we have, these are the document events here, right? Not too many. And stuff like scroll in might be important, especially if you're, doing some sort of parallax effect and that. But hopefully we don't have to dig into this level, right? Hopefully, in that. Window does have quite a few events and stuff. And so, I mean, if you're going to do some gaming development where people are navigating in that, but there's a lot of stuff for hooking up gamepads in the JavaScript API that maybe you don't have to come into the actual window events and do it. You just hook into something like a map view and turn on game controls and that. But you could be definitely someone, hey, did someone click on a button, right? Or did someone click on my div? But there are a ton of events in that. And like I've just discussed in other courses, exceptions are mandatory, but events are completely optional. You don't, the list of events on an HTML element is very extensive in that. But ones we like, on change, when you change the selection in a select box. On click, did you click the div? Did you click the button? That kind of concept in that. But it keeps going. Copy paste, how does that work on your particular element? Something that you might get involved in is a drag drop event. So lots of people, hey, can I just, I have a shape file here. I just want to drag it onto the map and have it add all the data and that sort of thing. And so drag and drop is you could get involved in that. And there is a sample out there in the JavaScript API doing client-side queries that does tie into the drag event. You dragging the mouse over the map changes the selection, which changes the data that feeds the charts. So there's lots of some stuff for gestures in that. Lots of stuff about mouse events, mouse down, mouse enter, mouse leave. That's how a lot of your hover. Well, here, watch. Right, mouse enter. The tooltip pops up with the link in that. So, in that, I'm inside an HTML document right now. So these are events that are in play in that. And so the pointer leaving and entering, like a button gets highlighted, so you know that it's active or something. If I click right now, this is the button that's gonna fire off. Wheel, right? I'm using the scroll wheel right now to go through this list. It's something that you might want to look into. So these are events would be like if you have like your own div or you have your own type of element set up on the page. If you're going to go to a map view, better tie into its events as well. It may not be as big as this, but this is the full list of anything that can happen on an HTML element. And again, these are completely, optional. Do you want to listen for that event? And do you want to write a handler, some code to do something when one of these events gets triggered and that? And that was the element list, crazy big list in there. But that's the reality. But again, like I said, they're all optional. And if you're not listening for them, nothing happens in that. Right? So what do you need to do? So you need to create a function to act as the event handler. So you'll have to write a function somewhere, and then you'll need to register that function as the handler to say, hey, on this event, right? It's usually like add action listener, and then you go, what event do you want to listen for? Click, change, wheel, and then what function runs, and then the name of your function. So what you can do now is pause this audio lecture and watch a quick demo just on events. It won't be too in depth, but just show you the basic registration. We've seen this in previous demos, but in this one we'll just focus on clicking on things and that. So what I want to talk about now is navigating JavaScript styles. So as you work on different projects, look at different samples, to get ideas or poach code or something, you're going to run into a lot of different styles. So it can be frustrating. I'm just going to acknowledge that and that, but we'll talk about it. So there are many JavaScript coding styles in that, and it depends what framework I'm in, and I guess who you might have inherited code from, your own personal development of what's working for you and what's not working for you in JavaScript, and that. So first thing is JSON, and this happened to me on a recent project where I was trying to set the style. It's a style.json thing in LibreMap, and I was getting killed in that, if I was honest. But that's because I was in code, but the code needed to do JSON stuff, pure JSON stuff in it, right? And that. And so is the problem. One would be the thing I'm looking at right now. Am I in JSON or am I actually in JavaScript? That'd be the first thing. Where are you? Let's, are we in data land or code land? In that. And so how would you tell? Right? There might be a .json extension that gives it away, right? But you will find the dead giveaway that you're in a JSON file is that there's double quotes on the key names. Okay, so you see what you might think is what we call it object literal, and but all the keys have double quotes, which I usually don't have to do if I'm in code land, and that gives you the hint. Hey, maybe I'm somewhere else, some other part of the multiverse, in that. And so double quotes on all non-numeric and keys. So you see double quotes everywhere, not singles, doubles. I ran into that. Then there's like, okay, no, you're actually in code land, right? You're not in JSON land in that. And so you could be, plain old JavaScript, nice and calm, kind of like the Zen of the 90s when everything was good and stuff like that. And that. And so this is not bad, right? This is where a lot of us start it. This is how you get a simple sample up in that. And then you definitely start to get object literals. Now, object literals come into play in the JavaScript API because all their constructors are there's a constructor, and it can be empty, or it's a constructor and you send it in options, and those options are organized as an object literal. So if you're in the JavaScript API, you're going to see it a lot in that. And so what it is kind of looks like JSON, except no double quotes on the key names, and that's so you know, okay, I'm still in JavaScript land, but this just happens to be a JavaScript object literal. You'll see it in the chart samples, demos, and that. There's a lot of object literals happening there in that. And there's JavaScript classes in that. And so it's a different style. You'll see functions and you'll see a lot of key names, colons going to functions in that. You might even see the word class, but it definitely has a different style. I cannot lie in that. And then there's the node nested callback hell, right? And so this style got really popular, right? In that, and people would explain the code, and then it almost became like a cult, like we have to do it this way. No, you don't. In that, and so. But it is this concept of where you have a function inside 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 a function, and what your code gets indented, and you're off the screen in no time. And if a brace ever goes missing or a parentheses, are you in trouble? And you got to hunt down, well, where did it go missing? Who's missing? In that. Interesting variable scope issues on this, or solves a problem for you. Issue for you solves a problem for someone else in that. And so it is this nesting, right? And that there's a good example. I think it's on the could be the server side example, or maybe the client side sample. Watch, you'll see a lot of nesting on one of those. And that promises and promise chains. And so I've used those because I really like the way the fetch is set up to get data. So I like the fetch.then.then. I like promises because there's a .catch built in there. So it's got built-in error handling. So I like. It's a one-liner, just so you know. A lot of those promises are one-liners, those chains, even though we organize them over multiple lines so you can actually have a hope of reading them and understanding them. They are a one-line wonder. In that there's these lambda arrow functions, right? Popular with also around promise time, and you'll even see it in some nested stuff. It's a real quick way to write functions without having to say the keyword function, without having to give the function a name. And sometimes you can get away with, if it's a really short one-line function, you don't even need the braces, so it can solve things really quick. But it can be used a little bit in the nested callback, right? Promises, these are one-liners, so they want these things to be short in that. But they can get out of control if you let them. There's also await async, and I've gone down this path and then jumped out, right? And that sort of thing. Async await is good if you know that async wait will always be okay. Nothing's going to go wrong with that async await. With me, well, I need to write up stuff and try catches. And so what happened then, and this is the battle for me between promises and async await. If there's an available promise around, that's my go-to because it's got the built-in .catch in there. But if you do async await, it competes with promises, and they can be intermingled and stuff. But then you got to do your own error handling with try catches, and then your code starts to get really noisy quickly. Not quite as noisy as the nested callback with arrow functions and that. But I just find on a simple fetch that does need error handling, the promise style actually works out nice. The code looks good and it's readable in that. But these are all different features, right? And so this is why all these different things can make one chunk of JavaScript code look very different than another in that. And then, then we can get into how our framework does things as well. Maybe I should add framework to the list in that. And then there's the hybrid mix where, hey, within the same JavaScript file, there's a little bit of plain old JavaScript, and all of a sudden some object literals, and a short nest with an arrow function, but then a promise over here, and that, and someone threw in some async await in that, messy. But that's that whole JavaScript developer parity, messy language, right? And there is all these capabilities. Another comment I heard from an ESRI developer, I believe it was, JavaScript is Play-Doh, right? That sort of thing. What you want, there's all these different styles. It's just, it's whatever you want it to be sometimes in that. And so that can be, this is where that gives you some freedom. That freedom can lead to a complete unmaintainable mess and that. And so it's okay to have some standards, some structure around yourself, your team, about how you're going to implement your JavaScript code and techniques. And like I said, I was in promises, async hit, hey, let's go try out these new features. And I'm like, oh no, looks horrible. They worked. They could work the same, but for me for the project I was working on, I was like, no, this is. I just had one of those moments with myself and said, no, this is actually worse. I'm gonna go back to the other way of doing it, and that. So what you can do now is pause this audio lecture and look at the demo on JavaScript styles. Switch gears here and talk a little bit about the portal and that. And so you can work with the portal with the JavaScript API. And I would put this in the area of a Python library called the ArcGIS API for Python. They could always be changing the name. At first, I didn't understand what that library meant, but what it means is in Python, you're talking to the portal. And so it'd be nice someday if they put, portal or ArcGIS Online in the title somewhere, because it's very specific to that technology stack in that. And so what can you do with the portal part of the JavaScript API SDK? Well, first you need a portal, so they have a portal object. So you need to be able to connect to it. Big things you want to do in a portal, and this you see this in the JavaScript API too, because they're both talking here and there. We're both talking to the same REST service, and it's the REST service that really builds the box that you're in. You query it maybe. You usually have to query it for users, for portal items, and that sort of thing. That's how if you're going to talk to the portal directly. Okay, it's like this big massive database with all this stuff in it. Are you interested in the groups, the users? Are you interested in a particular user's items, like their maps and layers? And so you do start at that level, all right? And you can, a portal folder you're probably not going to get unless you first get a user and say, hey, get me their folders, and then you get a portal folder. And that portal group, are you part of the GST8010 group? Portal item, that could be anything. I think the enumeration in the Qt library for the type of portal items might be at 140 something. You definitely break 100 different types of things that you can encounter between like Experience Builder, Instant Apps, App Studio apps, shape files, geo packages, feature services, image services, GeoJSON files, you name it. There's a and that. Just so the number of the different types of portal items is very interesting in that. Uh, there's a lot of them. Portal item resource, query parameters. This is the big thing. Like I said, when you get a portal, you gotta. The big thing is you query it typically to find all these things: folders, groups, items, and resources. But to do that, you can build up a query parameters, and you get a query result that typically have the list of folders you were looking for, the groups, the users as well, a portal rating, the portal user, and that. So for me, although my code's written in Python right now, right, things I have to do is clear out accounts once a year, and that. And so I got to go find the user, find all their content, and start deleting it off. I'll jump over to symbols here as well. So, I mean, there's lots of concepts around symbols. So you kind of like have to back up and say, hey, let's before we get to red, point, line, and polygon, right? Or point, line, and polygon is probably best way to start before we start thinking dash lines and colors and that. So there's this concept of point, right? There's a point on the screen, and you're going to put a marker symbol there, or maybe like a character out of a font set. Markers have been done so many ways. There's lots of different types of markers too. Is it like a picture, like which would be like a PNG or something like that? So there's lots of different ways of doing points in that, or maybe scalable vector graphics if we're up at the marker thing in that, or we're doing some font awesome stuff. That hit a while back in that. Is it still the fad? It's a good question in that. And then there's lines, right? So again, this is conceptual level. Like okay, just think like a point, a line in that. So we have lines with widths, and if they're dashed, and they'll have color and that. Polygons. So then we probably have fill, and they'll have like an outline. Maybe it's called stroke. It's like the different words for this and that. But new things, mesh. So we're talking 3D stuff and that. And then text, interesting text would be, you might go, well, why can't I just have a point that has a bunch of text? But sometimes, the concept of where you have a map and you're going to draw on top of the map and have a text box and that kind of stuff. There's a little bit of overlap with fonts and things, but it's really for putting text on the map. Would we say label points? I'm not going to go quite there in that. But possibly is where you could have the concept of a label based on a point and what goes at that point in that. So, but there are these concepts that we see, right? Points, lines, polygons, mesh, possibly text in that. And then if we're in the context of, this would be, web maps in general, whether they're coming from ArcGIS server, Geo server, because there's even an OGC standard for SDL, symbol description language, and that. It's XML spec and that. But if we're in the context of ArcGIS and the web, then we're probably talking about the cartographic information model in that. Worth a quick look. I think they're on version 3 in that. But this would really be the userized world in terms of the web. I'm not going to say Map or Pro because I have used symbols in ArcMap that I couldn't actually publish to online because there wasn't an equivalent. So there's a little bit of a translation there happening. Now I'm not sure if is it that every symbol in Pro will be supported automatically on the web? You could get into a little bit of a gotcha situation where you picked a symbol that wasn't. That still might exist, right? So again, this is from the horse's mouth from their site. Specification is used for maps, scenes, layouts, layers, symbols, and styles in ArcGIS applications and APIs in that. So this is them, right? The hope would be that if you do something in Pro, it'll be part of this SIM, cartographic information model, and then it will automatically be supported on the web. So you should never get into a situation that I got into in Map where I accidentally picked some symbols that weren't, and then there was no way to actually ahead of time to say, hey, right, are you a web supported symbol? You just had to pick some symbols and see if they went up, and if they didn't, pick different ones. And if you got lucky, out there, it got published, kind of concept. So when they say ArcGIS application, it feels like pros should be able to do it. But like I said, like I got into these situations where I picked a symbol on the desktop product, and uh, I wasn't able to publish the layer in that. So that would be a thing, a huge effort to have a consistent symbology, or what they call their cartographic information model. One thing too is this spec is when it's the, I mentioned SDL earlier, being XML. This is a JSON spec, and how you describe symbols in JSON in that. And it's in the the license is in the public commons. So this might become a standard someday, across, any GIS web product would be able to use it and choose if they want to support it or not. Okay, little breakdown, right? To match with those, like I said, there's the concept of the points, lines, polygons we got, but there's also this text concept and meshes for 3D. And so this is sort of like a little bit of breakdown in it. In terms of, it's a little bit of a side, but in terms of object-oriented concepts and inheritance, this is where you see a lot of this happening on the symbol side. Like there's this concept of a point symbol, and a marker symbol is a type of point symbol, which is a type of symbol. So there's lots of hierarchy I found in these symbol libraries, because in the end, it's complex in that. And so, like here, if we just read through the table, got a point symbol, you got a vector marker symbol in that, or a picture marker symbol. Vector marker symbol, scalable vector graphics as your symbol in that. In that picture marker symbol, this, and again, they say picture because like relates to old school terms, but it's usually an image, like a little PNG, little graphic. Maybe it's a JPEG. Maybe it's a GIF. We have to get in there and see what actual image formats are supported, so we don't design a bunch of symbols that don't actually work in the end. In that, you got line symbols again, vector marker symbol, picture symbols, and solid strokes in that, or picture symbol stroke. Even on solid strokes, probably where you get into your dash lines and stuff like that. And that, and so is it aligned with a different type of effect in that. And then polygon symbols, vector marker symbol, picture symbol, and that. And this is like, you got to distinguish between the fill patterns versus the stroke, or the outline they call it. In that, it's funny. It's the stroke is, what's that? That's a scalable vector graphic term. In that, but it means the line part of your symbology when we're talking polygons. In that, so this is the breakdown of the specification. Would be, I guess if you start now, you probably focus on this. You want to make sure this is the part in that. But there's always some legacy stuff, backwards compatibility, the standard way of doing symbols since the day of ArcMap and that. I do have some thoughts on symbology in that. So do as much work as possible in the web map, right? That's what you want to do. So the more time you spend there, it pays off on your app, just so you know, right? So do, right, as much work as possible in the web app. Avoid doing symbology in code, right? And there's cases where you can't avoid it, but if you can avoid it, do it up in the web map in that. So even doing one symbol, hey, I want all the dots to be red. We're like 4 or 5 lines of code already, probably. Then there's renderers, and there's the classic unique value renders, class break renders, and there's a whole bunch of new renders under smart mapping that do similar things. And that renders increase the amount of symbology, therefore that increases the amount of code, right? So this is the concept that, hey, my map is going to come to me raw, right? No symbology, and I'm going to put all the symbology on it. So if you're going to do like a unique value renderer that has like comes back with 15 different values, that's 15 different symbols you have to do. Points you might luck out, but if we're talking polygons, times that by 2 because we can set the line and the fill pattern, and so our could get into the hundreds of lines of code if we really need it to be this dynamic, okay, and that. And so a unique value render, class breaks, dictionaries, you go from one symbol to many symbols, right? Multiply, it's a, multiply the number of lines of code, right? And then if you're doing color ramps or heat maps. That results in many, right? If you're doing smart map color, right? We should go take a look at that. It's funny because what you find is these concepts of unique value class breaks, they start to repeat over in smart mapping. So it's like a whole other different set of uh, way to do renderers in that class break renderer. But we already have one over under renderers as well, right? So we have renderers over here too, right? So now it gets into, well, whose rendering are we talking about? The regular renderers, classic, we'll call them classic, or smart mapping ones in that. And so then even code wise is, uh, in that, are we getting out of control? I don't know. But I'm just saying that if you can, right, work in the web map. Get all that worked out in the web map as much as possible. I mean, as you know, you have time to sit there and do different color schemes interactively as you're doing your map, save your map, get it set up the way you want. To do this in code and then to rewrite a whole bunch of code to do the colors because you didn't like the colors and that. And if you're not in a good editor, you can't even see what the color is. If you're lucky in VS Code, it'll give you a little block that says that that's what that color means in that. But what if that, VS Code doesn't pick up on that? And then you're like, I don't even know what the hashtag F1A324, what color is that, right? So, and that sort of thing. So do it in the map if you can in that. A little bit of reality though, right? So like I said, do as much as possible in the map. But where might it not be possible? Well, if your app has a graphics layer, like that has nothing in it, you're going to throw stuff in there, in that, then you need to give that graphic some symbology in that. And so if part of your app is a graphics layer, then for things, like I said, I'll repeat it, to show up, it needs symbology. So otherwise, you're not going to see it in that. So if you need to re-examine a topic or need clarification on a term or concept, or just have a question, you can get an answer by posting a note on one of the discussion boards for this course. This concludes this lecture.